Hey everybody, hey, this is our lecture on dimensional analysis using conversion factors. So, imagine this. You're driving along a highway in Mexico when you notice this sign. The speed limit has changed to 80 kilometers per hour. Awesome, you're thinking, I get to drive 80 here too, just like I do in Texas. Well then, wait a second. What should your speed be in miles per hour? Well, what we're going to do today is we are going to discuss the topic of dimensional analysis using equivalent statements and conversion factors to help us to get there. So grab your notebook and grab something to write with. I want you to write these notes down. The first thing you want to know is an equivalent statement. It shows two quantities with different units that are equal to each other. For example, one dozen of eggs is equal to 12 eggs. That's an equivalent statement. 1 dozen equals 12 eggs. There are several different ways that we can express equivalent statement. The first one is counted numbers, just like the example of 1 dozen eggs is equal to 12 eggs, Also, 1 pair of shoes is equivalent to 2 shoes. Notice how these items have been counted. There are 12, you can count them, 1, 2, 3, 4, all the way up to 12 eggs in 1 dozen. The next type of equivalent statement is one in which the numbers are in the same measurement system. Such as if we were in the metric system, we would have 1 kilometer is equal to 1,000 meters. That's an equivalent statement. Also, in the standard system, we would have 5,280 feet is equal to 1 mile. Next type of expressing equivalent statements would be if your numbers are in different measurement systems. For example, if we were just looking at mass and we wanted to know how kilograms are equal to pounds, this would be the equivalent statement that we would use. 1 kilogram is equal to 2.21 pounds. And for length, 1 inch is equal to 2.54 centimeters. Okay, the fourth type of equivalent statement would be if we had numbers specific to a certain situation. For example, on a map, a scale on a map, or a scale on a photograph. 1 inch on a map could be equivalent to 50 kilometers, and or 1 meter that we would see in the photograph would be, or say that again, 3.45 centimeters in a photograph could be equivalent to 1 meter. Another example could be 1 lab group would have 3 students in it. You're going to see this in our activities that we do this week, that there are going to be 2 or 3 of you working in 1 lab group together. So that is one way of writing an equivalent statement as well. Okay, now what I want you to do in your notes is I want you to just design 4 equivalent statements and write them down in your notes. All right, I'll give you some time. Go ahead and pause the video at this point and design 4 equivalent statements. If you can't think of anything, open up your favorite browser and just search for different equivalent statements and then write them down. Okay, next. We are going to take a look at conversion factors. Conversion factors, well, they're factors we're going to be multiplying by. What they are is they're a set of fractions. I know, fractions. Don't let fractions freak you out. Fractions are your friends. In these conversion factors, the fractions are always equal to 1, in which the numerator and denominator have an equal value. We come up with these conversion factors by using the equivalent statements. Every equivalent statement can be used to make or construct 2 conversion factors. All right, so if we take a look at this example, if we have 13 steps equal to 1 flight of stairs, the way that we would do this to make our conversion factors, we just write it straight from left to right. If we were to take 13 steps, okay, that would be what we put on top, or what we could take, well, I'll do this one first. We would take 13 steps on top, and then we would see here, and we would have 1 flight of stairs. I'll just abbreviate that with an FL. Okay, or what we could see is we could have one flight and we would put 13 steps on the bottom. These would be two conversion factors for this one equivalence statement. Next. Now, what we're going to start getting into is this idea of dimensional analysis. What happens in general anytime you multiply a number by 1? Well, it ends up being the same number, doesn't it? So for example, if you were to take 4 times 1, what do you get? You get 4. All right, so we're going to be thinking about that. Remember, whenever you multiply a measurement by a conversion factor, it's the same thing as multiplying that measurement by 1. What we see here is that since the fraction or conversion factor is equal to 1, when it's used in a calculation, it does not affect the value of the number, but it does change the units. So that's what we're trying to get into here, is understanding the idea that even though we have a number that is a measurement, the size of that measurement isn't really changing. What is changing, though, is the unit and how it's being measured. Lastly, dimensional analysis is a process in which a conversion factor is used to convert a value from one unit to another. And we're going to be practicing this a lot. All right, now, one of the first things you need to do once you know you have to convert from one unit to another, you need to decide which of the conversion factors you're going to use from the known value is going to cancel the units to give you the value that you're looking for. So let's practice a little bit so this makes a little bit more sense. Okay, here's our first problem. We're going to convert 3.5 hours to minutes. Well, the first thing you need to do is any time you're solving a problem is you're going to write down the given information. And you're going to place it over 1 like this. Okay? Next, what you're going to do is you're going to get up a conversion factor so that the information in the numerator and denominator equal each other. All right, so remember, our original question wanted us to go from hours to minutes. So what is the equivalent statement for hours and minutes? Well, we already know from all of our previous experience in telling time, right, that 1 hour is equal to 60 minutes. Okay, so we're going to use this conversion factor in such a way that we're going to end up with minutes on top and hours on the bottom. And we can see here that we've got our original given information, and we're multiplying by the conversion factor of 60 minutes over 1 hour. We can see here at this point in time, we need to cancel our units. If we've got hours divided by hours, they cancel each other. And once those units cancel each other, we see right here, we're going to multiply the numerators. So if we take 3.5 times 60, we can even do this math in our heads. If we take 3 times 60, we get 180, and then half of 60 is 30. Add that to 180, we get 210 minutes. All right? Then what we're going to do after we multiply the numerators is we're going to multiply the denominators. What we have here is we've got 1 times 1, and that's going to equal 1. So in our final answer, we have 210 minutes divided by 1. And once we take care of that, we're going to have 210 minutes over 1, which gives us a final answer of 210 minutes. All right, now what I want you to do on your own is go and think about our original problem, 80 kilometers per hour. What is that in miles per hour? Let's have a discussion when you get to class tomorrow.